In this segment, we'll talk about what do we mean by a transpose of a matrix. So let A be a M by N matrix. Then B is called the transpose of A if Bji is same as Aij. So what you're basically doing is that you are exchanging the row and the column. So whatever is the ith row jth element in A becomes a jth row ith element in B. So you can very well see also then the size of the matrix will be n by m. So the size of the matrix B will be n rows and m columns. And we'll see that through an example as well. Also what people say is that, hey, if you can write if B is the transpose of A, you can write B is equal to A transpose. That's another way of symbolizing this. So let's take an example of finding a transpose. So let's suppose we take 5, 6, 7, 9, 19, 29, 31, 34, 39, 61, 67, and 73. So let's suppose somebody says, hey, this is your A matrix, and what you want to do is you want to find the transpose of this A matrix. So the first thing which you have to realize is that this has 4 rows and 3 columns. So 1, 2, 3, 4. So 4 rows and 3 columns. So our transpose of the matrix will be now 4 rows and 3 columns. No, 3 rows and 4 columns. So we'll have 3 rows and 4 columns because we had 4 rows and 3 columns in A, and now we have 3 rows and 4 columns in the transpose of the matrix. So this is first row, first column. So this stays as first row, first column, because if we're going to switch the row number and the column number of A, so 1, 1, it is still 1, 1. However, if you go to this particular element, which is first row, second column, this becomes second row, first column of the transpose, which will be 6 right here. And same thing here, this one is the first row, third column, but in the transpose it becomes the third row, first column, so that will be a 7 right here. So you can very well see that this will become 9, 19, 29, 31, 34, 39, and then 61, 67, 73. So that's how the transpose of this particular matrix is going to look like. Let's do a spot check here. So let's suppose I have this element as 39. This is third row, third column, and 39 is right here. That's also third row, third column there. Let's look at another element right here. This is fourth row, second column. And let's see if this 67 is now in the second row, fourth column of the transpose, which it is here. That's where 67 is, and that place is second row, fourth column. So you're finding out that's the transpose of the matrix, where all of these elements have been, where the row number and column number have been interchanged so far as elements are concerned. And that is the end of this segment.